Welcome to this tutorial video, and we'll be solving an exam question. The question is in two parts. Kindly pause the video and solve the question on your own. So the first part of the question, we're asked to find how far the spring is compressed, and you have to understand to say the energy at the top of the plane is the same as the energy at the bottom, and all of this energy goes into compressing the spring. So with that in mind, we'll simply say the energy, potential energy, will be equals to K, the spring constant, x squared divided by 2. Potential energy is simply mgh, will be equals to K, x squared divided by 2. We've already been given the values for our spring constant, which is 400 Newton meter. Our mass is 3 times 9.8 gravitational acceleration times the height. Spring constant is 400. So in this question we're solving for x, which will tell us how far the spring was compressed. When you do your calculation, this part of the equation, you should get this value. And when you divide your 2 in 400, you should get this value. Solving for x, we divide both sides of the equation by 200. And finding the answer for x, we have to take the square root of 0.5, which will be 0.71 meters. So we have found by how far the spring is compressed. We have solved the first part of the question. You guys will comment in the chat section what formula you used to find the answer for part A. Going to part B. In part B, we are told to say if a coefficient of friction 0.2 was added, okay, then the thing has to find how far does the block slide on the horizontal surface while compressing the spring. Okay, so again, we need to put into consideration to say, in this case, all of the potential energy goes into compressing the string and also overcoming the friction. So what we're going to have is potential energy will be equal to K squared divided by 2, then plus, we also consider the friction in this case. So it will be mu, friction is given by mu times normal force, mg. In this case, also considering the distance, which will be given by x. So again, we'll be solving for x in this question. Potential energy simply mgh equals to kx squared divided by 2 plus mu mgx. Replacing in the values given, we have 3 times 9.8 times 3.4, which is equal to, you should have 200 here when you divide the 2 into 400, x squared plus the mu given there, coefficient of friction is 0.2, multiply that by 3, which is the mass, and 9.8, and our x that side. This other side of the equation, you should get this value. And on the other side of the equation, we should have our 200x squared plus 5.88x. So this is a quadratic equation, and we can put it in order. So we have a 200x squared plus 5.88 x minus 100. Now we solve for x, and we'll do that by using the quadratic formula. So this will be Writing down the quadratic formula, this will be negative b plus or minus the square root of b squared minus 4ac divided by 2a. Replacing in the values from the quadratic expression we had on the previous board, this will be negative 5.88 plus or minus this will be the square root of 5.88 minus 4 times 200 times negative 100, which is the value for c. 4 is divided by 2 times 200, which will be 400 in this case. Solving in what is under the square root, we should get plus or minus, this will be equals to, inside the square root you should get this value. You don't round it off at this point. Make sure you do the rounding off at the end of the answer, the final answer. Okay. When you take the square root of the value there, we should get negative, so this will be x is equals to negative 5.88 plus or minus 283. That will be the value after we take the square root divided by 400. Now in this case, we'll not consider the negative side of the answer because we're dealing with distance, and distance is a scalar quantity. So in this case, only consider the positive answer. And when you do negative 5.8 plus 283 and you divide it by 400, you should get the answer 0.6928, and the final answer will be 0.7 meters. So this is how far the block will slide on the horizontal surface given the coefficient of friction 0.2. You guys, if you found this video educational, you can subscribe, leave a like, and leave your comments in the chat section. Thank you.